We'll be covering the carpometacarpal or CMC joint of the thumb. The CMC joint of the thumb is the first carpometacarpal joint of 5 total. The CMC joints in general are articulations located between the distal row of carpal bones and the proximal bases of the 5 metacarpal bones. The CMC joint of the thumb is a synovial articulation located specifically between the trapezium and the base of the first metacarpal. Because of its location, this joint is also known as the trapeziometacarpal joint. The CMC joint of the thumb is classified as a sellar joint, also known as a saddle joint, and has 2 degrees of freedom. As we learned from the first unit, this means that each of the bones of the articulation, the trapezium and base of the first metacarpal, have a convex and concave surface. This differs significantly from the other 4 synovial carpometacarpal joints that are classified as synovial ellipsoid joints that only have 1 convex and 1 concave member. The trapeziometacarpal joint also has its own separate joint cavity, is a saddle joint, and has this specific shape. It allows for a wider range of motion than the other CMC joints. This is important as the thumb is required to spread wide to grasp large objects as well as move inward to participate in a pinch grip. The CMC joint of the thumb also allows the thumb to move in the same plane of the hand, as well as anteriorly perpendicular to the palm. The trapeziometacarpal joint is what gives us humans our unique opposable thumbs. Now Hannah will be explaining the function of and details of movement at the CMC joint of the thumb.
Hannah, what did the finger say to the thumb?
I'm in glove with you. The CMC joint of the thumb is a complex joint that allows for many different motions. The thumb CMC joint is capable of flexion and extension, abduction and adduction, axial rotation or circumduction, and opposition-reposition. All of these movements give our thumb a wide range of motion and contribute to the fact that the thumb is involved in 40 to 50% of our upper extremity actions. Flexion and extension at the CMC joint occur in the frontal plane, about the joint's anterior-posterior axis.
Abduction and adduction, on the other hand, occur around the mediolateral axis of the thumb. With abduction, the thumb moves away from the second metacarpal, and with adduction, the thumb moves towards it.
These movements combine to make up the most important motions of the thumb: opposition, reposition. Opposition involves palmar abduction and flexion and allows us to bring the distal end of our thumb to the distal ends of our other fingers, aiding in pinch grip. During opposition, the first metacarpal pronates or medially rotates to allow this movement. Reposition, then, involves palmar adduction, extension, and lateral rotation or supination to bring the thumb back to anatomical position. Opposition is used when gripping a key to unlock a door, when snapping your fingers together, or while manipulating a video game controller. Circumduction can also be seen at this joint and is similar to the movements you might make to escape your opponent in a thumb war. Many muscles involved in the movements of the CMC thumb joint. Because the CMC joint is the most proximal joint of the thumb, any muscle exerting a force on the thumb will also exert a force at the CMC joint. The amount of force exerted, though, is dependent on where the muscle inserts. The 3 thenar muscles act directly on the CMC joint and form the bump on the palm called the thenar eminence. These muscles are the opponens pollicis, the abductor pollicis brevis, and the flexor pollicis brevis.
The opponens pollicis originates at the trapezium and inserts on the lateral metacarpal. It aids in flexion and opposition. The abductor pollicis brevis originates on the scaphoid and trapezium and inserts on the lateral proximal phalanx. It assists with abduction and is the primary muscle involved in opposition. The flexor pollicis brevis originates at the trapezium and inserts at the base of the proximal phalanx. It allows flexion and opposition in the thumb. Now that we have discussed the shape and movements that occur at the CMC joint of the thumb, I will now cover the structures that stabilize the joint. As previously mentioned, there is a large range of motion that occurs at the CMC joint. The capsule surrounding the CMC joint is relatively large and loose to allow these movements to happen. This is where ligaments are needed to stabilize the joint. The ligaments of the CMC joint have three functions: to control the direction of joint motion, to maintain alignment of the joint, and to control forces produced by the muscles on the joint. These functions are important to understand, as inflammation or repetitive injury may lead to the ligaments becoming excessively lax, which can then lead to instability in the joint. The ligaments are also involved in preventing subluxation of the thumb, which often occurs after injury or with osteoarthritis. There is a debate within the field as to how many ligaments support the CMC joint, and different names are often used. However, one ligament that is important to note is the anterior oblique ligament, which is highlighted in our picture here, as this ligament is often associated with arthritis.
These are two main nerves that are involved in the carpometacarpal joint of the thumb. The posterior side of the joint is innervated by the radial nerve. This superficial radial nerve runs along the radius down the branches into a terminal digital branches that supplies the dorsolateral aspect of the hand, as well as the dorsal aspect of the first 3.5 digits. The median nerve branches off in the palm after entering through the carpal tunnel, where it innervates the thenar eminence. From there, it innervates the adductor pollicis brevis and any opponents of the pollicis muscles.
Ah, my thumb hurts.
Injuries can be very debilitating for this joint. We don't realize how much we use this joint until we're no longer able to do so without pain. The high functional demands placed on this joint consequently lead to the highest rates of osteoarthritis in the hand joints. This then leads to a loss of function. The functional importance of the thumb is underscored by its effect on disability. Loss of thumb function imparts a 40% to 50% rate of impairment to the upper extremity because of its central role in nearly all grasping and handling maneuvers. Fractures are a common injury that can occur at the CMC joint. A fracture can occur on the first metacarpal bone or on the trapezium. When a fracture occurs on the first metacarpal, it is generally from a trauma that has been inflicted or extended, or the bone has been extended. This type of trauma would be from a direct fall or when a person catches a ball and it pulls the hand back. Indirectly, it could be happening from a twisting or a muscle contracting, such as during wrestling, hockey, football, or skiing. This type of injury is called a Bennett's fracture. The trapezium is the other bone that can sustain a fracture, yet it's the third most common carpal bone to be fractured after the scaphoid and trapezoid. When this bone is fractured, there is generally another carpal bone or the distal radius that have an injury as well. A fracture to the trapezium generally occurs after a full dislocation as well. A dislocation with a fracture can occur after a foosh, generally while grasping something or riding a motorcycle and being thrown forward while holding onto the handlebars. Dislocations occur and more prominent when a person has the range of motion that is greater than a normal joint movement. This is called joint laxity or joint hypermobility. In addition, there is a higher prevalence of CMC osteoarthritis. Once a person has dislocated this joint, subluxation of this joint can occur from not sitting in the saddle correctly or has a weak capsule. The radial subluxation of the metacarpal on the trapezium has been noted with functional activities when a person has joint laxity. This continuous wear of the extra stretching on the tendons and poor gliding of the joint can lead to osteoarthritis. Thumb use without significant rest are associated with a higher prevalence of osteoarthritis. Some of these jobs are manually milking cows, or a typist who is consistent with her dexterity. A dressmaker, tailor, and embroiderer are occupations that put the CMC joint in a vulnerable position. Another prevalence for osteoarthritis is coal miners, who needed to move heavy loads with wheelbarrows.